Good morning, everybody. I'm really happy to have you all in this seminar. Welcome to the second online seminar hosted by the WorldDAB SNCC committee. And my name is Hans Walter, and I'm the chair of the Spectrum and Network Implementation Committee, so the SNCC. And usually I work for DAB Italia, which is a leading DAB-only network operator in Italy. In Italy, our company has been at the forefront of this growth for DAB, and we have a network of around 240 transmitters, giving coverage of about 89% of the population. The network in Italy is growing, and so is DAB in Italy, and the same happens to other countries in Europe. And in this context, we are really happy to dig into some technical aspects of building DAB networks, and that's why we have these seminars. And I will start with a short introduction of exactly about the SNCC committee. So the first thing is, what is the SNCC? The SNCC stands for Spectrum and Network Implementation Committee. It will provide guidance on regulatory approaches, on technical aspects. One of the tasks of the committee is to provide radio spectrum for DAB applications and development of networks. And the SNCC also will give advice and best practice example on a number of technical items. So transmitter site building, multiplexing, sound processing, monitoring, and signal distribution also. And one very important thing is that the SNCC also wants to be really a platform for the exchange of experiences. And that's also one of the reasons I really invite all of you, if you're WorldDAB members, to join this committee. Let's move on to the seminar. This seminar will deal with the DAB+ coverage in panels. So we will have a number of aspects we will deal with, like advantages and trades-off of different technologies to bring the DAB signal in the tunnel, different functionalities and capabilities for emergency break-in systems, and of course, also how legal and financial aspects of tunnel systems are dealt with in different countries. That's the agenda. We'll have 3 high-level speakers. The first one will be Lars Peder Lundgren from Paneda. We will then have Roberto Moro from SRG SSR from Switzerland. And last but not least, Georg Plattner from RAS, Rundfunkanstalt Südtirol. He's the director of the agency. And we will have a Q&A session after the seminar. There is a Q&A button on the Zoom. Please write down your questions there. It's very important for us. And yeah, let's just dive into the presentations. I'm really confident that this seminar will be really informative and engaging for all of us. As I said, please, I encourage you to participate to the Q&A session. And I will also remind all the participants that this seminar will be recorded, so it can be also viewed later on. So with this, I have nearly finished. We will have one more seminar in March. We will still have to find out a new title for this seminar, and we'll also have a meeting of the SNCC also in March. So if you're WorldDAB members, you're really invited to participate. And thank you very much for this. Let's go back to the first speaker, who is LP, Lars Peder Lundgren from Paneda. The floor is yours.
Thank you, Hans. As you heard, my name is Lars Peder Lundgren from Paneda. very few words about Panida. We are a Norwegian company active in 3 different main areas. In Norway, we operate and own our own DVB-T2 network. Currently over 100 transmitters in operation nationwide in Norway. Of course, we are active in the tunnel segment where we do radio systems in road tunnels and especially DAB break-in systems. We are also a leading supplier of DAB head-end systems, where we currently have over 200 systems in operation worldwide. The topic of today is, of course, tunnel systems. It's all about coverage, of course, but it's also a system that can do what we call a break-in system, a system that can interrupt the transmissions in case of any emergency. There are also some safety rules to consider. There is, for example, one European Union directive that are stating that tunnels longer than 500 meters or with a car density of, I can't remember, 5,000 cars per day or so, must have a safety systems. That directive is quite complicated. It's about safety in overall, but where radio systems is one part. So there must be a rebroadcast system for emergency in that directive. By the way, on the left-hand side, you see the world longest tunnel. It's a Leerdal tunnel in Norway, 24.5 kilometers. Anyway, coverage. If we divide coverage in longer and shorter tunnels, we have shorter tunnels, and again, less than 500 meters. It's not very complicated. It's about a pickup antenna. We have a low power amplifier, and you can connect the directive antenna or Yagi antenna in the tunnel, and you can easily have good coverage in the tunnel around 500 meters. One thing you need to consider is interference. It's quite easy if you have too much gain or too much power on that output that you create a loop, an interference loop back to the pickup antenna. So that's one thing you need to consider. Normally you just place the directive antenna a little bit inside the tunnel, so it can't leak out very easily. So coverage in short tunnels is rather uncomplicated. FM and DAB, the principle is the same. And again, the directive. FM break-in, when we talk about analog radio, it's also quite straightforward. It's just about kind of an RF switch. Normally broadcast the off-air signal straight into the distribution system in the tunnel, power amplifier or a radiation cable connected to that, leaky feeder. And in parallel, you have an FM transmitter or FM modulator with all your FM frequencies in a kind of a standby mode. And you do the switching on RF level using that RF switch. That's FM. Let's focus on DAB instead. A DAB break-in system is actually quite complex system. It requires perfect timing, perfect signaling, and everything needs to be in sync and in phase. The principle is that you have a pickup antenna, you have the selective amplifier, that's important, because you don't want to broadcast signals into the tunnel that is not containing any break-in functionality. So you need the selective amplifier, and again, also connected to a kind of an RF switch, where you, in the normal situation, you just rebroadcast the off-air signal as is. In parallel, we need to analyze the off-air signal with the concept that we create an identical copy. So we kind of have a new DAB multiplexing system with encoders and multiplexers. So we create an identical copy of that off-air signal in parallel, but of course with the audio replaced. And audio input can be audio over IP, dial-up systems. You can dial up the system and speak. We have audio inputs, line in. We have microphone inputs. It can also be pre-recorded files connected to the system. Of course, we also need a modulator, CFDM modulator, or a transmitter if you prefer. Very low power connected to that RF switch. and you trigger the system, or actually the switch over from off air to this emergency break-in signal over physical inputs, TTL, connected to different kind of external trigger systems. You can also do it with API commands or directly in the user interface. So this is the basic block diagram of a DAB break-in system. The Panida system has that built in a hardware unit. It's a 1-unit hardware, we call that PBS, containing 2 ensembles per hardware unit with all these blocks included. So you just connect your IP network so you can control and monitor the unit. You connect your RF output to the distribution system and connect audio, triggering, and RF input from the pickup antenna. Basically, not very complicated. The second part is the distribution, which varies a lot, and it's also the most complicated part. It requires good RF planning, and the exact setup depends very much on the existing infrastructure. But for shorter tunnels, maybe even without radiation cable or leaky feeder, it's sometimes possible to use a directional antenna of a Yagi type, for example. But of course, not possible, not easy for longer tunnels. But again, you have your DAB break-in system with the pickup antenna. You connect the RF output from the system to an amplifier, and you connect your distribution system, whatever it is. And reception is also regulated in at least in the areas we are acting in, saying that it has to be at least minus 82 dBm as minimum, but recommended is 76. And that's something you always need to measure, of course, by using driving tests through the tunnel. So you can see that the signal is not dipping too much in their lowest part. And of course, there can be amplifiers connected as well if the tunnel is longer, of course. And also in at least in Norway, it's also regulated that you feed both ends of that cable for redundancy purpose. So that's quite common actually that you do that. So again, the RF planning should aim to provide as little power as possible inside the tunnel, but still to fulfill the reception requirement, of course. But it's not normally the case that you have a 200-watt transmitter in the tunnel exits and entrance. That will create many other problems with too high reception, for example, and interference and otherwise, and also loop back to the pickup antenna. So there are a number of things you need to consider when you do your RF planning in the tunnels. Maybe a more common setup, at least in Norway, is that after the DAB break-in system, you have a low power RF output, and we convert that to optical. So we have an RF to optical converter, and we are feeding repeaters inside the tunnel that converts back to RF. So RF to optical and optical to RF. And in that way, we can cover longer tunnels with repeaters inside the tunnel, easily 1,000 to 1,500 meters per repeater. And on the repeaters output, we of course have RF connected to the radiation cable. The repeaters, the output of the repeaters are of course adjustable, so we aim to have as little power output as possible to fulfill the reception requirement. There are also variants of this setup where you feed the repeaters from both ends and redundant optical fibers, etc., etc. Depends on the requirement. Another common need is that you may have 2 different tubes, one in each direction, quite common. And then the question is, how do we do separate break-ins? We normally don't want to do a break-in in both tubes if the problem is located in one tube. Well, dual system is of course the easiest. So you have two separate braking systems, one for northbound and one for southbound, as in this example. That's easiest, of course. But we also have technology to do what we call differential braking systems, still having one system. It's based on the principle that you have one off-air RF on the output, and you have one break-in output from the DAB braking system, and you connect that to two different switching systems. And in that way, you can have separated break-ins for these tubes with one single DAB braking system. In Norway, all tunnels in Norway are owned and managed by the national road authorities, where each tunnel is connected to a control center, a traffic control center. And it's not only one in Norway, they are also distributed into regional traffic control centers. And the traffic control center, they control and monitoring the complete ecosystem in the tunnels. It's not only about the radio systems, it's about the road signs, different kind of message boards. They control the fan and the ventilation systems, cameras, etc. In fact, many tunnels are quite complex with sensor technology. In Norway, they have systems where they are measuring even the heat on the brakes of trucks, for example, and prevent them to enter the tunnels. So it's a complete ecosystem where radio system is just one part. And it's also the traffic control center that activating a break-in, and they can do it in different ways. They can dial up the tunnel using SIP phone. So they dial up the system, enter the PIN code, and they can choose to either speak live into the tunnel or play a pre-recorded message. But there is also most tunnels in Norway also have a microphone panel installed outside the tunnels. It's an emergency red box where firefighters, for example, can open the kiosk and grab the microphone and activate the break-in locally where they are. So that's quite common as well. All right, is this expensive? Yeah, maybe it's expensive, I don't know, but this aimed to save lives. So if you ask me, it's not very expensive. A typical cost for a typical tunnel. This tunnel is around 10,000 to 1,500 meters, for example. A typical cost is with a pickup antenna, a DAB braking systems for 2 DAB frequencies, 2 ensembles, with a power amplifier and 2 microphone panels, one at the exit and one at the entrance, including installation work. A typical cost for that is 50,000 euro. Another great thing that we are using in combination in break-in is alarm announcement, the DAB standard alarm announcement. It's quite nice actually. It's used in combination, and it's forcing DAB receivers over to DAB so they can hear their message. And it doesn't matter if they're listening on FM or Bluetooth, CD, or whatever it is. Most receivers support this, and it's actually working very well. And some receivers also turn on from standby, so that's quite nice. Plus that the audio volume goes up, so it's an improvement for reaching people in tunnels, and it's pretty well supported. Also, metadata is it's rather nice. In Norway, the road authorities has standardized a number of graphics, text and pictures in several languages, so they can reach foreign drivers in the country, for example. So they have standardized a set of different graphics for different accidents. There is an issue of this feature. It's working well, except that many car receivers put a big screen on top of that metadata, saying that there is an alarm in progress, and actually hiding the actual metadata. So that's not really good. And if you ask me, it clearly violates the DAB standard 0.739, where it's saying that the receiver should present the metadata as it is from the source. So that's something I brought up many times with the automotive industry, and hopefully there will be an improvement soon. Here we have some pictures from different installations in Norway, where in the middle you see a complete rack with amplifiers, repeaters, RF to optical, etc., etc. And you see the pickup antenna installation to the right, and the repeater in the middle from converting from optical to RF. And that's all from me. And feel free to contact me or us. We can help you with any installation or tunnel works in general. Thank you.
Okay, LP, thank you very much for your really interesting presentation. As I said before, please send in questions for the Q&A. In the Zoom, there's a Q&A button, so write down the questions. I think there are a few interesting points LP has made, and yeah, very interesting presentation. Thank you very much. So our next speaker will be Roberto Moro from SSR from Switzerland, and he will tell us a little bit about the Swiss experience on tunnel coverage. Switzerland has a very complete, or let's say comprehensive coverage for tunnels. Yes.
Thank you, Hans, and good morning to all. It's a pleasure to having me here. Today I'm presenting on behalf of the Swiss Roads Authority. This presentation, I will go through several points within the past 15 years. First, the roadmap all started 2010 with people saying that it is not feasible to have DAB and voice break-in in tunnels. So we scouted for solutions. We made a study report on the principle of voice break-in, and the famous Swiss proof of concept was 2013. It was a showcase really showing authorities and stakeholders that it works. After that, we worked out a guideline for DAB in tunnels, as in Switzerland is everything regulated. And then the Roads Authority, which is, by the way, responsible for the DAB coverage and finances as well, has started the engineering work, tendering work, and the rollout. We have performed measurement campaigns. Then we have revised the guideline because we have seen that we have to increase the field strength signal in the tunnel. And already 2019, the project was closed. Okay, in the past 5 years, we have experienced extension of new tunnels and new ensembles. The proof of concept was done in a not so long tunnel with 1,500 meters, with only 2 ensembles, block 12C and 7D, with a voice break-in system which is applicable for both tubes of tunnel, with a level attenuator, so we could adjust the receiving level in the tunnel to experiment. And then, as Lars Peter has already shown, 2 fiber optical systems and 2 amplification sections for DAB. This was. On the other hand, we have chosen cars with DAB receivers. We have measured them from front, back, rear, and left. As you can see, quite different sensitivities. And at the bottom, a table which we have tested for voice break-in. You can see if the voice break-in is synchronized, as it was mentioned before, then the receiver reacts quite controlled and quite fast. If it's not synchronized, you can never know what happens with the receiver. The receiver here needs around 20 seconds. It's too long. So voice break-in has to be synchronized. The output of this proof of concept have been several study reports, project report, and the guideline I've mentioned. You can click by yourself afterwards here in the link, and you can study the guideline. Many stakeholders have been involved in this project. Of course, the Swiss Federal Roads Office, Federal Office of Communication, the broadcasters, ensemble providers, but also regional companies for engineering tendering projects, supplier of systems, system integration, and of course, suppliers of subsystems for DAB and voice break-in, further stakeholders, and WorldDAB as well as eView. The technical concept here is shown in the guideline, quite easy. Here is the receiving antenna, the reception stage, then the voice break-in, the fiber optic system, the amplification section, and then, sorry, the tunnel with the leaky cables. We only use leaky cables in Switzerland. Here is one tunnel. You have here the transmitter, you have here the receiving station, the tunnel. You have the level, you have 4 amplification system because the tunnel is quite long. You have maxima, minima. Minima are the critical ones. Here on the left side, you can see the terrestrial coverage quite high. And what I want to show you here is how fast this signal drops into the tunnel. So this is the reason why we use leaky cable instead of discrete antennas. We have analyzed several influencing factors. The place of leaky cable, it's not a good idea to place the leaky cable at the bottom. The impact of obstacles, for a low it can be up to 12 dB. Then the transition zone applicable for the operation of voice break-in, when you have 2 different DAB ensembles. In fact, to show how long this zone is, and on the other hand, the impact of DAB on the Swiss tetrapole PPDR radio service, which was fine, no impact. In the guideline, we have specified the reception and the emission in the tunnel to have a decent signal, minus 65 dBm at least, a decent carrier to noise ratio. We say that they should use directive receiving antenna, and everything is referenced for the error protection level 3A. In the tunnel, we demand a field strength of 52 dB microvolt per meter. It is 36 dB microvolt in the case with a referenced antenna, which is normal for measuring leaky cables. Also, the minimum carrier to noise is specified, the maximum intermodulation to other radio services, and then, of course, the minimum delay if the round trip is longer than 60 microseconds. So this is the case for tunnels of a length of more than 10 kilometers, then network timing has to be aligned. And this is where the tunnel project has to come into contact with the broadcaster. Signal reception, to remember, it is the important input criteria for the signal quality. It needs more field strengths at the reception antenna of the tunnel station than a car will need driving along the same place. The channel impulse response is replicated 1-to-1. That's why it should be improved before. Reception of many different ensembles in Switzerland. We have up to 8 of them in some tunnels. It's quite a challenge when they are not collocated. And in some special cases, we need 2 reception antennas and 2 head ends. For small-scale networks, you all know these. They are vibrant for the DAB market. It's, however, more critical to bring the signal to the receiver station. Yeah, that's it. Within the tunnel, the existing radiating leaky cables are used now for FM, DAB, and PPDR tetrapole. The minimum criteria for DAB coverage I have explained. It's based on ETSI standards and WorldDAB guidelines, and of course also on measurements we have performed in Switzerland for cars and aftermarket devices. It includes some margin as well for man-made noise from other systems in the tunnel. And this margin is helpful as well for cars or aftermarket devices which are not fulfilling the minimum sensitivity. Voice break-in, I will not go in detail. It was originally the motivation to start with DAB in the tunnels. However, voice break-in is in Switzerland not the only way to warn car drivers and is less relevant today. And it's definitely not in the perimeter of a Swiss broadcaster. It's quite complex compared to FM. And this is quite funny. Voice break-in is enforced by just replacing the audio content. There is no specification in any WorldDAB ETSI standard. It's not it's no signalization like, for example, traffic announcement or announcement in general. It's just the audio content is replaced synchronously, as I have said. What we have seen years ago is a very steep learning curve of voice break-in systems by means of system integration, size and costs during the past 14 years. Left for only one ensemble, 3 units. You can imagine what happens with that with 8 ensembles. Then a better integration, and on the right-hand side, a Swiss product comprising 12 ensembles and as much audio codecs as you want. Lessons learned we had during the planning and specification phase. It was very important and crucial to understand what cars are needed, to learn from the specifications, to understand the voice break-in as a general. And the Swiss proof of concept was very helpful to showcase the feasibility and also to have the background for the guideline. During the rollout phase, we have experienced that receiving small-scale ensembles could be a challenge. So we have to increase capability, and we have experienced this impressive learning curve for voice break system. Today, during the operational phase, according to the Swiss Roads Authority, Federal Office of Roads, and its regional offices, all tunnel systems and voice break-in systems are running stable and fine. However, they say, as I have said, it's not their main business to warn people through this installation. It's more seen in the meantime to improve the user experience for DAB coverage for drivers driving within Switzerland. Different receivers, different receiver and antenna performances are seen as a challenge. And that's why, well, DAB, automotive working groups, aftermarket working group, and UX working group are very helpful to improve that. So that's it. Thank you a lot, and I'm open for questions.
Okay, Roberto. So thank you very much for your presentation. Also, very, very interesting presentation indeed. As I said also earlier, please send in your questions through the Q&A button in the Zoom window. We will take the questions at the end of the seminar. So we'll have a prolonged session there. Now let's move on to our next speaker, Georg Plattner, Director of RAS, Rundfunkanstalt Südtirol, the broadcasting company for South Tyrol. Georg, the floor is yours.
Thank you, Hans, for the opportunity to present different technologies we have been using the last 25 years in South Tyrol. But first of all, I would like to give you an overview where RAS is located, who we are, and what we do. We are located in South Tyrol, the northernmost province of Italy on the border with Austria and Switzerland. There are 3 language groups in South Tyrol, Italian and the 2 language minorities, German and Latin. The RAS is a public organization of the autonomous province of Bolzano, and RAS is 100% financed with public funds. RAS was founded 50 years ago with the task of providing South Tyrol with radio and television channels from the neighboring German and Latin-speaking countries. Today, RAS serves more than 1,200 transmitters and microwave links on 120 transmitter sites. Due to the mountainous landscape in South Tyrol, we have a very capillary transmission network. RAS currently distributes 22 digital TV channels via 3 DVB-T multiplexes, 4 FM radios, and 37 stations on 3 DAB networks. Here you can see the 37 radios we broadcast in South Tyrol via DAB. From Italy, we broadcast 4 RAI stations and 15 local private radio stations. From Germany, 9 radios, from Austria 4, and from Switzerland 5. With 114 DAB transmitters at 57 transmitter sites, we achieve a coverage rate of about 99.6%. And RAS started DAB broadcasting very early in 1997, more than 25 years ago, because for such a mountainous landscape as we have in South Tyrol, we were convinced that DAB is the best transmission technology. And we immediately recognized also that coverage of tunnels is very important. One of the most important transport routes in Europe crosses through our country, the A22 highway, Autostrada del Brennero, from the border Brennero to Modena, which with several tunnels along the route from Brennero to Bolzano-Bozen. And initially, we tried the simplest method to cover the tunnels with transmitters outside the tunnels. Sometimes it's the easiest way to cover the roads inside the tunnels. But however, it works only for very short tunnels with a length of a few 100 meters. Here you can see, for example, the A22, and this tunnel is covered from outside. Then if the tunnel tube is also lined with metal, then the reception is much better than with a concrete coating. We made measurements with the result of propagation in tunnels with metal lining is much better. However, early in 1998, we began to equip the tunnels on the Brenner Highway with their own tunnel system. The two longest tunnels of the Brenner Highway already had an analog tunnel supply for emergency services and for 3 analog FM radios. We expanded the existing analog system with digital services using simple combiners and no longer used old band 3 iso-frequency repeaters. This allows us to amplify all DAB blocks in one TV channel at low cost using old television repeaters. The power of these repeaters is usually 2 watt. And here you can see in this picture the 5 multiplexers that we transmit in the tunnel by using only 2 old TV band 3 repeaters. Here on the left side, you can see the 3 blocks on channel 10 and the 2 multiplexers on channel 12 on the right side. And here you can see how the tunnel system is realized. We always install a receiving mast outside the tunnel on which the receiving and transmitting antennas are mounted. Good reception must be guaranteed outside the tunnel. The receiving signals then is amplified in the equipment room and then transmitted into the tunnel via radiating cable. We have always 2 different radiating cables for RX and TX systems. To avoid interference, especially with analog signals from outside, the radiating cable should only start around 20 meters inside the tunnel. And on the right side, you see the different types of radiating cables. In the following 25 years, together with the road maintenance service and the civil defense of the autonomous province of Bolzano, we began also to cover the tunnels of the federal and provincial roads. The road maintenance service, together with the civil defense service, set up the infrastructure, the mast and the technical room, and then RAS installed FM and DAB transmitters in the technical room. Complex system for all emergency services, broadcast services, and mobile phone were then installed. In these tracks, you can see on the right side the FM and DAB part, and in the middle the combiners. On the left side, you see the part for the emergency services, fire and rescue services, the up and down converters, the intercom unit with the FM transmitter, and the optical converters. Actually, we supply 39 tunnels with a total length of around 40 kilometers. The tunnels are between 300 meters and 3 kilometers long. Our aim is to equip all tunnels with a length of more than 500 meters with these systems and to supply them with DAB. In the list on the right, on the left side, you can see also that we use one single feed-in system for several tunnels. Here, for example, in Valbadia, we use one system for 5 tunnels, and these tunnels are then connected by fiber optic links. Today, more and more broadband systems are being used in new tunnels. As you can see, the original simple transmission systems are being replaced by more efficient broadband systems. the configuration of the new system you can see on this slide. On the left side, you see the RX and TX antennas with the HF coupling. And then you see the DAB and FM broadband amplifier repeaters for the emergency services, the Tetra repeater, and then on the top you see the optical converter that converts all the signals, and then with the fiber optic links you bring all the signals into the tunnel where to the respective tunnel section, and there is a separate amplifier for each section with a length of about 500 meters. And in this case, you see two sections of about 500 meters each. As you can see also in this picture, we use broadband amplifier for FM and DAB. This is a very simple device that amplifies the entire FM and band 3, totally broadband. Here nothing needs to be changed for new switch-ons or frequency changes because it's totally broadband. And on the right side, you see the HF coupling and the different fiber optical links that brings the signals to the different tunnel sections. As you can see here in these pictures, we have usually also an intercom option in the tunnel. In the case of emergency, an announcement can be made via only one FM radio frequency. But we have seen in the past that in an emergency case, the emergency service usually don't have time to go into the technical room in the tunnel and make an announcement there. However, as our tunnels are not staffed, it is usually more efficient to make a central announcement over the entire DAB network. And that you can see here. That's our DAB playout. And in our case, the South Tyrol Civil Defense at its headquarters, you see it on the bottom on the left side, have direct access to our audio matrix. And in case of emergency, they can switch off all our audio radios and transmit the urgent message via all radio programs. That's much faster and more efficient. Finally, I would like to mention an important point about tunnel coverage. It's very important that you are already involved in the planning phase. It's very important to choose the right location for the receiving mast and the equipment room before the building phase. All signals from radio services, mobile phone, and broadcast must be received well outside the tunnel. Accurate measurements must be made during the planning phase to determine from which directions all signals can be received with good levels, and where is the best position to place the receiving antennas. You can see from these photos how different the reception situations are and from which directions all signals arrive. It is usually difficult to make corrections afterwards. We made often major compromises in the reception situation because the radio or mobile phone signals could not be received while outside the tunnel. It is also important to be able to check all installations and to be able to take measurements in the tunnel before the tunnel goes into operation. Correction and changes to the installation are difficult to carry out when the tunnel is already in operation. So that was a brief overview of what we have realized over the last 25 years and which technology we have used over the years. Thank you for your attention. And that's all from South Tyrol.
Excellent, Georg. Thank you very much. Very interesting presentation also. First of all, really, I want to thank all the three speakers for their presentations. They have been really great. And I'll move on to questions. I've got a couple of questions which have come in. Once again, if you have any questions, use the Q&A question, the Q&A button on the bottom line of your Zoom window. So the first one starts really immediately very technical, and this question goes to all the three of you, basically. Considering the different organization of the tunnel breaking systems and the management made by different companies, how do you monitor all the systems in the tunnels to ensure that they are really working when they are needed?
I can answer that if you want. As I mentioned in my presentation, all tunnels in Norway, I can only speak for Norway, of course, are connected to the traffic control center, normally over IP, of course, with their own IP infrastructure. So they always know the status of the system and have full control and everything. And we also have RF monitoring products installed in many tunnels. So we can immediately see if there is a lack of RF signal inside the tunnel. And we also have, as backup, we have a 4G and 5G connected devices. So we can remotely from our end, from a provider perspective, connect to every tunnel and see the RF strengths and coverage and so on. So they are very well monitored, of course. So that's the answer.
Okay, Roberto, do you have any information on how Swiss tunnels are monitored?
Yes,
is there a body?
Swiss tunnels are not monitored at all. So this was a decision of the roads authority. Neither the DAB coverage system nor the voice breaking systems. They just perform periodical tests. And of course, it is recognized by the car drivers if something has failed, and then it comes back to us as broadcasters and we inform the road authority, but no monitoring in Switzerland.
Okay, thank you, Roberto. Georg?
Yes, in our case, the broadband systems are controlled by the civil defense, but the simple tunnels aren't controlled or they haven't any control system. Only the broadband system, the newer generation, have the possibility to have a control signal and send all the signals to the headquarters of the civil defense.
Okay, yeah. LP you want to add something?
Yeah, I think One difference I have noticed is that comparing to Switzerland, I think, is that in Norway, the break-in functionality is used very frequently in Norway, many times per day. So the road authorities, they do a break-in for many different reasons, for just traffic information, informing people that is a traffic jam ahead, and also informing drivers that there is an ambulance approaching, and all these kind of things, traffic jam, traffic information. So they're using it quite frequently. I must just adding that information. So per design, it's actually tested many times per day and monitored, of course.
Okay, thank you, LP. Another question. This goes, I think, also to all the three of you. And the question is: are always all the ensembles which are available at the entrance of the tunnel broadcasted, also rebroadcasted in the tunnel, or is there a selection?
I can start again.
Yes, please. You're the first one.
And not always, actually, because in Norway it's the tunnel operator, which is the road authorities in Norway, who decides which frequency that are allowed to rebroadcast into the tunnel. And it all comes down to the regulation. If the tunnel is longer than 500 meters, that signal must be equipped with a break-in functionality. And if you have a broadband amplifier and rebroadcast everything, you will violate that European Union directive. So in Norway, they are saying that they have control of which frequencies that are rebroadcast into the tunnels, but they have an ambition in Norway to rebroadcast all the license holders outside the tunnel, which is in most cases in Norway, it's 4 ensembles. One for public, one for national commercial, and 2 local regional frequencies. But if there pop up another license holder, they will add whatever device that is needed to activate break-in and rebroadcast in that tunnel.
Okay, thank you, LP. Roberto, I remember probably that Switzerland takes all the services on air into the tunnel. Is that correct?
That's right. The regulation is to bring in all ensembles which can be received with a car outside to bring in the tunnel. And as you know, that the mobile reception is quite easy. You have a lot of overspill. We have ended up with many ensembles to be brought into the tunnel, as I have said, up to 8 from different regions, which are, for example, some French-speaking ensembles in the German-speaking area of Switzerland, because they are can be received on the road. That is for safety reason. It's not safety by means of voice breaking, but safety by not fiddling, by no driver distraction, not fiddling around with the receiver. Yeah.
Okay, Roberto, thank you. Georg, I think in South Tyrol you do like the Swiss do. You take everybody on board.
Yeah, of course. We bring in all the multiplexes, what you can receive outside the tunnel, and we amplify all the signals with the broadband system. This is the newer technology. On the beginning, as I mentioned, we brought in only one channel. But now we amplified the whole band 3, and DAB works very good. It's quite simple. We have more difficult to amplify the FM radios. That's much more difficult. Therefore, our aim is to broadcast the DAB signals. They are clear, and you get a good reception into the tunnel. but FM it's very difficult to have good signals outside, and because we have this mountainous landscape, and normally tunnels are really between the mountains, and you have a lot of reflections, and therefore DAB is the best technology, and so we point really to the DAB coverage into the tunnels.
Okay, Georg, thank you very much. I think this is a question more for Roberto, because we have a question which says, are there pre-recorded announcements used in tunnel break-in systems? And where are these recordings stored and how are they triggered?
Yes, thanks for the question. As you know, in Switzerland, we have the cantons, the regional cantons, 26 of them, and it's the responsibility of this police cantonal to define the messages. They are predefined, and they are, of course, some of them are restored. And if you drive through the Alpine Tunnel San Gottardo from north to south, or from south to north, you will experience a voice break-in, a permanent voice break-in as well, in this specific tunnel.
Okay, Roberto. Yeah, thank you. I can confirm this. I tested that a couple of years ago. In this context, I have one more question for you, Roberto. In Switzerland, do you have an indication of how many cars have a DAB radio at this point in time? Also, in let's say in preview of the switch off of FM for the public service.
Yeah, this is a very good question. We have already 60% equipped with DAB. But on the other hand, 40% is missing, as no DAB. So we are going to switch off FM as SRG end of year, and the road authority is switching off FM in the tunnel as well end of year. So this will be then the challenge that I would say 40% of car drivers are looking for an aftermarket device solution.
Okay, thank you, Roberto. LP, a very technical question. Since the internal structure of the flow of DAB is modified by the voice break-in, are there problems with the SFN synchronization or with the signal saturation of this break-in system, or not?
Yes and no. In all normal situations, it's the off-air signal that is rebroadcast into the tunnel, so it's identical. So they are the same. So that's okay from an SFN point of view. During a break-in, the content is of course not the same anymore. So inside the tunnel we have one signal, and outside the tunnel it's another, and that will create interference at the exits and at the entrance. There is nothing we can do about it, of course, because the content is different. So yes and no is the answer, but it's just during the break-in.
Okay. I have so many questions to choose from. I think a question for Georg, but also for other speakers. How is it, from a legal point of view, covered that the Civil Protection Office, or let's say the Road Authority, can replace the audio of the commercial radio stations? Or is there anything defined, or is this just open because it's an emergency system?
That system we use only for our radio stations. This possibility that the civil defense can switch the audio matrix it's only for the RAS radio stations. The private radios have their own system, and the urgent message is transmitted via their programs. And this case that the civil defense has access to the DAB matrix is only for our DAB playout. It's not for the private radios.
Okay, thank you.
And we don't use speaking systems in the tunnels because it's too complex for us. We use only the switch on the DAB playout in our playout.
Okay, thank you, Georg. LP, but also maybe Roberto. How can you be sure that the voice of the audio level of the voice breaking systems has at least the same level as the program on the receivers? Do you do some tests, or is there a standard, a specification for this?
I can start answering. Yes, we equalize the audio level so it match what is off air. But in addition, and as I mentioned in my presentation, we also use the alarm announcement feature, and that is quite clever actually, because in most cars they are highering the volume when it's an alarm announcement. So even if you have the lowest volume on your car receiver, when you enter the tunnel, the volume goes up, which sometimes scares people, of course, but it's quite a nice feature and it's working very well.
Okay, yeah, thank you. Roberto, I have a question for you. If I understood correctly, in Switzerland, you use only leaking cables with a feeding through fiber optics, fiber optic cables to the different repeaters. Is that correct? You don't use antennas or other hybrid systems.
That's right, because long time ago, before FM, experts have performed measurements, and they have concluded in what I have shown you in this specific tunnel, that the propagation of FM and DAB, and of course of PPDR, which is happening on 400 megahertz, is not really working in those tunnels, because perhaps our tunnels are a little bit reduced in size, in diameter, compared to Italy. I don't know exactly, but this was a decision. I'm aware, for example, from presentations from Railway in Italy, that they're using discrete antennas, but I think this was never an option, and so it is. Leaky cables are a standard. Yeah, that's it.
Okay. Considering costs, LP, you mentioned that a typical installation for a 1 to 1.5 kilometer long tunnel in Norway will cost about 50,000 euro for 2 ensembles. If you scale this up, I suppose that the equipment, let's say upscaling, will not add so much cost. It will only add to the part you have in the entrance. Is that correct?
Yeah, exactly. It's adding up with modules for each ensemble or each pair of ensembles. So technically you add more modules, and it's very hard to say how much it scales in money, but the biggest investment is in the amplifier system and the distribution system and the combiners and all these kind and microphone panels or whatever it is. So that's not the most expensive part to scale it up, which we are doing regularly in Norway when their new local radio has a license and the new frequency, and then we just need to add that as well.
Okay. Yeah, thank you. Last question also for the break-in systems is LP, you also mentioned that there is a delay in the break-in systems of 180 microseconds. Is that correct?
Yeah,
So
it's
the remultiplexing will take 180 seconds or microseconds?
no. It's about, I mean, we spent years in developing our tunnel system. It's quite complex actually, and it's the switching functionality. When you switch on RF level, that has to be exactly in sync, and you have to do it within what's called the null symbol within the guard interval. And that is, so you actually only have 180 microsecond for the switching part to make sure that you are 100% seamless on all car receivers when you switch to the emergency braking. So that's where the switching time, 180 microsecond, comes from. There is no delay between the off-air signal and the real signal, and the emergency braking system. So that's just the switching. It was just a number to try to explain how critical it is in timing when you do a switch over. You have to do it within 180 microseconds.
Okay, thank you, LP. Very interesting. One question for all of you. Do you work with the car manufacturers to get the systems more effective and also to inform the manufacturers on how they need to improve the receivers?
I can start again. Yeah, I mean, it's been many years. I think we had our first braking system installed 2010, something. We started that project with a lot of research, a lot of testing, and at that point we cooperated with many car receivers. We noticed some cars that have a clever decision-making process in their background, that the audio was replaced and then they muted because the audio was disturbed in their detection. So we have been working in close cooperation with all the car manufacturers, and every time we see a car that has a kind of a bad implementation, we contact them and we're sending test files, etc. And I think honestly, all cars are now good. I don't know any cars that isn't 100% seamless when it comes to emergency braking. And we are always in contact with the car industry anyway.
Okay, yeah, thank you. Roberto?
Well, concerning car receiver performance, we are heavily measuring and contacting car manufacturers through all these WorldDAB platforms and communities, but not only for the tunnel, mainly for the terrestrial reception on the road. In our alpine regions, it is very important. And if it comes to the functionality of voice break-in, we are not in contact with the car manufacturers. As I have said, voice break-in is has to be synchronized, but is not relying on any specification. So we cannot say you have to fulfill this or this or this. It's all about cheating the receiver with another audio. That's it.
Okay, Roberto. Georg?
Yeah, in the past we had contacts with the car manufacturers, especially when they went to South Tyrol to make measurements and they go around. So we made the measurements together and also to improve the receivers. And when we know some bugs, so we did tell them and to improve the reception on the receiver and the display and also the information that you can show it better what we send, especially also slide, so or the dynamic text information. So we made measurements in the past with them together in the field.
Okay. More questions, still more questions coming in. Just to wrap up a little bit on the costs. So we know in Switzerland, it's the road authority who finances the DAB coverage in tunnels. In Norway, LP, who's paying for this?
It's the road authorities.
Also.
Yeah.
Okay. And Georg in South Tyrol.
Yeah, here's the public hand. The autonomous province of Bolzano finance all the tunnel infrastructure, especially outside the mast and the equipment room, and also inside the leaky cables or radiating cables. We install all with public funds, and the costs are very different. It depends which costs you bring in or which systems are already available. If you have to build all new, so you have to spend about a few €100,000. We speak about 500,000 euros if you have to build all the system infrastructure, mast, receiving antennas, radiating cable inside, and fiber optic links to the different sections into the tunnel. It's very expensive if you have to bring in the whole system. If you have to only to install the DAB, it's cheap in our case, especially if you use old band 3 transmitters, so they are available, so it costs quite nothing. But of course, you have always to install also the receiving antennas and the amplifiers or the HF coupling or the combiners. So only for the DAB, you have to spend between 20 of 50,000 euros.
Okay, good. Excellent. LP, one more for you. It's your day. How do you approach the proper synchronization between the off-air and the tunnel DAB signals? So if you're outside in SFN, also if you have maybe if the outside signal is receiving from more than one side, so you will have two or more signals arriving. How do you synchronize that?
It's actually a very good question to start with. It's quite complex. What we are doing in our system is that we have a functionality where we do have a reclock functionality in the system. So we are locking to the off-air signal and regenerate the PPS signal more or less from that off-air signal. So we are locked to the off-air signal. So if that system is locked or not, it really doesn't matter. So we are just locking into the same phase as the off-air signal, so we can guarantee SFN and everything. But it's also possible to use a satellite receiver, of course, with PPS and 10 megahertz to be locked to GPS. But we don't do that. We prefer to lock to the off-air signal. Whether it's right or wrong, it doesn't matter, as long as we have the same phase as the off-air signals. And it's per ensemble. So if so we are locking our system to the off-air signals, even if there are 1, 2, 3, 4, or many, individually, one by one.
Okay. So I think, thank you very much. I think we have had enough questions for now and for today. I must say I enjoyed this Q&A session a lot. I think I have learned a lot. The questions and the answers have been really, really good. So I think really thanks to the speakers. The insight has been really deep. And I hope that for the participants and for all the viewers, this seminar has been really useful. So yeah, that was it. Thanks once again to everybody. Thanks to the project office of WorldDAB for organizing the seminar. And with this, I would like to say goodbye to everybody and see you at the next seminar. I hope in person or otherwise online. Yeah, thank you very much.